Cock. You are the light of the world. Juhu! Hihi! Juhu! Vagy a Koki baba? Azt én mondom. Yeah. Under voltage protection. Since I have here ZVS, special totem pole driven ZVS with a really nice, almost fully square wave driving signal instead of the normal, the usual chaotic normal ZVS driver signal. So and I must protect it from under voltage so that the gate source will not cannot get too low input signal. Yeah, here I am stabilizing the input voltage for the totem pole stage I am stabilizing at 13 or 15 volts, whatever, with an emitter follower. But we need to protect the gate source from under voltage. And this is good for almost any applications. Here the stronger one, I hope I got it correct. The values are correct, I hope. And this is for 1.5 amp, since we use only a BD transistor. Yeah, this is it. Or you can choose BD 240. BD 240 you can use also. That's for 6 amp, I mean, or that's for 3 amp. That's the double. But then you have to choose here a lower value, of course, like 3 kilo ohm. Must be careful because the 431 reference IC can handle maximum 100 milliamp. So when this will activate it, pulls down the base to earth, negative, maximum 100 milliamp. Must be careful. Now I have set it for 30 or like that, no idea, must calculate, depends on the input voltage, so always calculate with the maximum input voltage. Okay, hysteresis. So like the TL reference chip will not act too fast. Some hysteresis we need on the activated output voltage. We drive back, we loop back, we feed back some extra microamps or milliamps to the reference voltage, a few volt, like that. If the input voltage will drop a little bit, and it will not act immediately, output will stay high, active. Okay, so set the hysteresis at least 100 kilo ohm, I guess, or 70 kilo ohm, whatever, you must try. Here you have to set 2.5 volt reference voltage always, of course, for the TL431 to activate the output. So if the presetted voltage on potentiometer 1 will not achieve this 2.5 volts, so if there is too low voltage on the input, then the BD 140 or BD 100 or BD 240 base will stay pulled up, so inactive. But when we achieve this 2.5 volt reference voltage on the potentiometer, the first on the reference pin. Then the cathode anode will act like 0.2, 0.3 ohm resistance, so it will pull down the base of the PNP transistor to ground. So like that we activate the transistor. Okay, and now here something similar but with MOSFET, so a little bit more complicated but more power, much more power, as you wish. This is it. Must be careful with the input voltage. You must always calculate the maximum base and cathode anode current and the maximum emitter collector current too. Okay, then we have some pull down resistor, voltage stabilizer for gate source, very important. Oh sorry, I forgot to. This is the drain, of course. Here is the source and this is the gate. It's logically, source is always more negative than the drain, so like input, output. The positive is the same, but we switch here the negative. Here we switch the positive. This is low amp. It's more difficult to find PNP MOSFET as a P-channel MOSFET. That's why we switch the negative in it. Okay, you can figure it out. There is also some feedback, hysteresis. Okay, on the second potentiometer. From the gate voltage, which is always 15 volts stabilized, we bring back some energy to the reference pin to make slowlier. By changing voltage we act slowlier on the output. Okay, this is it. I hope the values are fine. And this is it. Yeah, the condenser on the gate source helps to make stable the gate source voltage, and by activating the MOSFET, we charge up a little bit slowlier the gate source voltage. Like that, the output power comes like from 0 to high. Okay, the ampere. It's a soft start, other side. Soft start. Okay, so peace and God bless you all. Jesus is Lord and Savior.